Now we're going to study this famous function, which is Bernoulli function. So it's defined by x to the power x. And our aim will be to evaluate this integral between 0 and 1 of x to the power x. I don't think we're going to be able to evaluate this one in this video because it's going to be less than 5 minutes. But this one must be, or it's going to be close to 0.7. We will see how to get this result here. But first, we need to see the graph. Okay, first thing is that this function, f of x, x to the power x, is defined for x in the set of positive reals. Okay, so defined for x bigger than 0. Okay, we know that if we want to take the power of some x, we need to have the base bigger than 0. The second thing is that we want to find the limits. So the first thing is the limit of f of x as x goes to infinity. So here we can see that it is infinity, or we can just see that we can write this one as x e to the x ln of x. And we know that the exponential is continuous, so we can take the limit on top of the exponential, and we get plus infinity. Okay, for the limit as x goes to 0 from the right, this one here, we can do the same thing here by noting that the exponential is continuous. We can take the limit to the top, but we know that the limit of x ln of x as x goes to 0 from the right is 0. We have done it many times, and again we repeat that the power always wins versus the log. So here we think of the natural log as doesn't exist. It's only the x power. So when x goes to 0, as x goes to 0 from the right, this function x will go to 0, and e to 0 is 1. Okay, in this case we can extend the function. We can define from the right, okay, by letting f of x equals 0, f of 0 is 1. Okay, and the next thing is that we know that x is positive, the power, the exponent is going to be positive, and therefore f of x is going to be bigger than 0 for all x's in this set. I mean the set of positive. So here we're going to see that our function is going to be on top of the x-axis. It's going to be here, on this top here. And next thing is we're going to find where the function is increasing or decreasing. Okay, to do that, we compute the derivative. So f prime is going to be here. We're going to use the chain rule, and we're going to get e to x ln of x derivative. So we're going to have 1 plus ln of x e to x ln of x. Okay, we don't know the sign of this one. Here, this is always positive. This one, this is x to the power x, which is always positive. So the sign of the derivative is the sign of 1 plus ln of x. Okay, we can solve here. Okay, we can set this one equal to 0, and therefore we have the natural log of x is minus 1, and this happens when x is 1 over e. Okay, 1 over e, I think it's 0.3 something, so that means 0.3. So if x is, okay, let me do a small table here. So our domain is 0 plus infinity. So f prime, so this is 1 over e. So here when my f, here between 0 and e, this value is negative. Therefore, my function is decreasing. Okay, on 0 it has 1, and 1 it is On x, 1 over e, it's going to be 1 over e to the power of 1 over e, which is, I think, 0.6. And here it's going to increase to plus infinity. Okay? So here, I should have said this is negative here, this is positive. This should be here. So here it's decreasing, here it's increasing. Here, f prime gives me the sign. Okay? Sign of the, and from there I get the f is increasing or decreasing here. So here it's 0, 1, here it's 0.6 and plus infinity. Okay, for the concavity I need to study f second. If we do f second, we're gonna use f prime. So we have f second, it's gonna be 1 over x, e to x ln of x plus 1 plus ln of x squared times e to x ln of x, and it's gonna give me ln of x plus 1 squared plus 1 over x e to x ln of x. And this is always positive. Okay, this is positive, x is positive, this is positive, therefore f is concave up. Okay, so this is always positive. And now I can graph my function. Okay, to graph my function, this is my domain, critical point 1 0, I have 1, and 1x is 1 over e, that's 1 over 3. Power the value is 1 over e, it's 0.7, and here I see, okay, it goes to infinity very quickly. So my function should look like this. Okay, so this is my function, this is x to the power x. Okay, here this is 1 over e, this is 1, this is 1, this limit, this is the x-axis, this is the y-axis, sorry, this is the x-axis. Okay, and what else? So we have a minimum here at this point here. We will come back to that later. And my interest is this integral here. Okay, between 0 and 1, this area. That's the one that's gonna give me 0.7. Okay, because note that if we try to compute this area, it's like we have a square that has side 1 1, but we are missing this integral. That's why this integral is not 1, it's something less than 1, and 0.7 is the one that we are after. But we are not going to compute that one now to make the video longer. We will see how to do it. You can try and do it and see what you get. Thank you very much.